Next up, Thermo 21. Trying to solve this problem by looking at values from the table, not sure which temperature should be used. What are bubble and dew temperatures, and when can we use it? So this is a refrigeration cycle as well, and it's for R410. And then when you jump to the table R410, there's these bubble and dew temperatures, right? So it's an interesting question. This actually has never been asked before. So I'll share a bunch of things that I kind of found out looking into this question so that I'd be able to answer it tonight. But if you forget most of what I'm about to say, that's probably fine, because if I didn't know by this point, then it's probably not required knowledge, but it's maybe something that we should be aware of. So here's what I found out. There's two kinds of refrigerants, broadly speaking. There's zeotropic, hopefully I'm pronouncing that correctly, which means that it's a mixture of two or more refrigerants. And then there's azeotropic, which means that it's, well, actually, even azeotropic can be a mixture, but what they're striving for is that there's one boiling point. And that property is something that would always be achieved if you just had one refrigerant, right? It only has one boiling point. That's just a property of the refrigerant. But anytime you start mixing refrigerants together to make something else, you have the potential that you're going to end up with a zeotropic refrigerant. And that's the case with R410, because it's a 50-50 mix of two different refrigerants, R32 and R125, which have different properties and therefore different boiling points. But fortunately for us, when dealing with R410, the boiling point is nearly constant. It's not constant, but it's nearly constant. And that's why you'll see that these values are very close. They're off by, maybe a couple tenths or less. So for all intents and purposes, we can ignore this completely, and we can just kind of take the average of those two, or if you're even dealing with the tenths place and the hundredths place anyway, you might be rounding to the nearest whole number. So, but if you want to be really precise, you could maybe just take the midpoint of the two, and that would be close enough. But then just for completeness, to answer the question, what is bubble and dew? Those are the boiling points of the respective refrigerants in the mixture, since the refrigerant 410 is a mixture. So if you imagine the evaporator coil, and you've got this refrigerant flowing through, and let's say we're going from left to right here. So this would, well, let me not draw an arrow that way. I'm going from left to right. So your state 4 would be somewhere over here, and your state 1 would be somewhere over here. So we're absorbing heat from the cold space, from the space that's being cooled, as we go from left to right. And somewhere along the way, we're already a saturated mixture because we're coming from state 3. But at some point, we reach the boiling point of whichever one boils first. One of these two refrigerants in the mixture is going to boil first. That's the bubble point. So somewhere along the way, somewhere in the evaporator, closer to the inlet, we'll reach the bubble temperature. And then somewhere further downstream, closer to the exit, we'll reach the second temperature, which is the dew temperature. And then there should be some amount of superheat, because we don't want to finish the evaporator without being beyond the right side of the saturation curve, or at least at the right side of the saturation curve. So there'd be a little bit more distance in the evaporator coil after that point. But really, that's the difference. That's bubble and dew. And really, since these numbers are so close together, I probably could have drawn these points like this. And this would be the bubble, and this would be the dew, at least for this particular refrigerant. Maybe there's other refrigerants where there's more elements in the mixture and they have all different properties. I'm sure that this could get a lot more complex, but for a mixture of two, this is a nice kind of starting point for us to unpack that question. So hopefully that helped. I learned something looking into that. So yeah, interesting stuff.